So we can say, well, why do we need coding standards? Well, there's two main reasons for coding standards. The first one is to help develop quality software. So another standard, 9126, looks at software quality attributes. So the functionality of the software, plus things like reliability, testability, maintainability, portability, that are quite important in software quality. And they are recommended or mandated by most key software processes, the ones we've looked at today, plus many others. And basically, a coding standard has two main aims: to promote quality software, but also to define a safer subset of the programming language. If we look over here at the C++ programming language, this diagram represents the whole of the language, and these various subsets are subsets of the language which are coding standards. So they all share some common functionality, some common rules, but there's various other areas of the programming language where they differ. They perhaps have different rules for different targets. But the basic idea is to subset the programming language to steer you away from using language constructs that are perhaps very poorly defined, perhaps implementation defined, perhaps hard to understand, or perhaps open to misinterpretation and being misunderstood. So if we just have a look at some of the things there that they cover, so things like constraint violations. Typically, a coding standard should say, there should be no coding standard constraint violations. So these are constructs that are syntactically correct but semantically wrong. So you've just broken the rules of the programming language. So for example, in C, we could say sign char star p equal an literal string, and that is actually a constraint violation. That's some illegal C code. We've broken the rules of the C programming language. In C, a literal string has type pointer to char, not pointer to signed char or pointer to unsigned char. It's pointer to char. And that doesn't really matter whether a char is represented as a signed or an unsigned data type. It's still pointer to char. So there's a illegal pointer conversion going on there. Now, most compilers won't tell you about that. They'll ignore it. Most compilers don't worry about that subtle difference. But as far as the C language is concerned, that's breaking the rules. We have undefined behavior where anything can happen. And in a safety critical system, we definitely want to get rid of any undefined behavior. So things like null pointer dereference, buffer overflows, or indeed dividing by 0. If y minus z is 0, we can end up with a divide by 0 there, which is obviously a bad thing to have. And then coding standards also go on to look at things like unspecified behavior, where the behavior of the code is not documented. So for example here, we have 3 function calls. We're doing some multiplication and some addition. And although we know that our multiplication will be done before our addition from our laws of precedence, we don't actually know which order those functions will be called in. It's something that's unspecified. The compiler can call those in any order it wants. Most people think that, well, all we need to do is put some brackets in here and that will enforce the evaluation. It doesn't. It just enforces the precedence. It's not the same as the evaluation order. So does this matter? Well, maybe if all the functions A, B, and C modify a global variable, or we expect them to be called in a particular order, we can end up with our program doing something unexpected. So what makes a good coding standard rule? Well, we have a quote here from Paul Burden on the MISRA C working group. Making rules is easy. Making a good rule is more difficult. And there's no point having rules in your coding standard that aren't good rules. So basically, a coding standard consists of a lot of documentation for best practice and safer programming. But ideally, the document should be written in a way that it's small enough to be read and understood. can be understood by the average developer, doesn't use complicated language, it's clear, unambiguous. It's got helpful explanations and also examples as well. It's very important so you can actually demonstrate good code and bad code. There should also be a rationale for each rule to say why this is important and why you shouldn't use this particular construct. It should avoid over-regulating, being too restrictive, and it should avoid any unnecessary rules, like obvious things. It should also ideally be suitable for automatic analysis, because enforcing a coding standard by manual inspection is not effective. And the rules should either be black and white. They should be decidable. It should be this code passes or this code fails. If you had a rule where it was quite hard to decide if code passed or failed, that wouldn't be very useful. So it lends itself to static analysis of the source code. And there's a wide variety of coding standards available. MISRA is a fairly common one. There's also CERT-C for security, Power of 10 from NASA, JSF, AV C++ from Lockheed Martin, High Integrity C++ from Programming Research, and many other coding standards available.